So welcome everybody to this presentation on using AI Center for document comprehension and customer churn prediction. I'm Andy Menon and I'm joined by my co-presenter Aram Van Moors. I'll be speaking to you about document comprehension and my friend Aram here is going to be talking about the customer churn prediction. Aram, are you there?
Absolutely, Andy. I'm
Hey
very
Aram.
excited to be here alongside with you. And
All right. All right, my friend. Welcome and good luck.
thank you very much. I already know that you've got a very interesting and very exciting solution to share. So
Yeah.
go right for it. And
Yeah. Yeah,
let's
thank
go.
you, my friend. I'm curious to see what what you've got for us today. A little bit about myself. I am an integrations engineer for Intralinks SSNC, and I'm also an RPA SME. I'm the founder of my startup, RPA Vanguard. I was introduced to UiPath a couple of years ago, and since then, we have built a number of automations. And just recently, we onboarded the largest team of attended bot users to our resident orchestrator. And I stand here in front of you today as a UiPath MVP, and I'm very grateful for this opportunity to speak to you. And I thank everyone at UiPath and the community for making this happen. So, what is the problem we are going to be speaking about today? We live in a digital society with increasing number of documents, and humans need to read and spend a lot of time just to arrive at a reasonable comprehension of information. The problem is compounded with documents not supported by summary or index. And then major decisions are taken without understanding related documentation. If you talk to your congressperson, chances are they have not read the bill that they are voting upon. Finally, you have incorrect categorization and filing and delays when you look for documents. So, how can document comprehension with named entity recognition help you? First, you can simply pass the document to the AI skill without having to read it first. Now, unlike word count, the output of this ML skill will be much more comprehensive, as you will see during the demonstration. And if you give humans a comprehensive report, humans can quickly make sense of what the document is talking about. And the added benefit would be you can take the output of the document comprehension and make it as an input to the document classification workflow to build classification systems. So, what are named entities? Named entities are parts of text that are recognized and grouped under 18 predefined classes called entity types. I have listed the ones that are most common that we can associate with on a day-to-day basis. For example, persons consume products, organizations make money, events are held during certain dates, and then we all follow laws to live in society. These are just a few of them. There are 18 of them in total, and you can look up the documentation to get full information on what these named entities are. So how can we build a document comprehension system? This is one way in which we could arrive at a solution. Let's start at position 1. This is our input. I have a 1,000-page document. I put it into an automation flow that splits the 1,000-page document into individual single pages, and we build a unit file repository. The second automation is the heart of the process where all the action happens. This automation flow takes each individual page and submits it to the named entity recognition ML skill in the UiPath AI Center. And what we get out of that skill looks something like this. You have the file that you submitted, and the skill has recognized an entity, and it has assigned it an entity type, and it also has marked the exact position where that entity has been referred to in your file. Columbus, for example, has been identified as a person. Coca-Cola has been identified as an organization. So we could take these results and first build a named entity report. We could take this report and send it to humans for immediate consumption. We could also build a document database. And as I mentioned earlier, you could provide these as inputs to a document classifier system in document understanding. So what are the application areas? If you are a sales and marketing professional, you could look at all contracts where a major organization has been mentioned, or you have done business with a very notable person. If you are a legal scholar or a research scholar, you could look up legal documents where certain laws have been mentioned. If you are a historian or an academic, you could look for documents that have some events such as the Great Depression mentioned in them. So without further ado, let's get started with the demo and see how we could build such a document comprehension system. So what I have here is a UiPath app that demonstrates the different steps in a document comprehension system. The steps at the top are documented on the bottom left, and each step briefly shows how it functions. We're going to be starting with the first step named split. We're going to take a large document and split it into units of single pages. Now, the corporate finance document I have has 1,056 pages, and I've managed to gather some basic intelligence from this file. And to do it, I had to click the Find Next button 169 times. So I want to see how the document comprehension system can help me here. Now, I've already split the document to conserve time. You can see the 1,056 independent pages here, but we are going to be focusing on a subset picked from different segments of the full set. So we'll move over to the comprehend step where most of the action happens, as I had mentioned earlier. This is where we'll be submitting these sample documents to the named entity recognition skill in UiPath AI Center. But first, let's go take a look at the package in the UiPath AI Center and see how we are going to be using it in this automation. So I'm in the UiPath AI Center. I'm navigating to ML packages, out-of-the-box packages, language analysis, and here we'll find the named entity recognition package. Now, this package has to be converted into a skill before we can use it in an automation. So if I navigate to ML skills, you can see that there is a skill that has been created from this package. And if I switch over to Studio, this is how I would use a skill within a project for the automation that we are going to be running in a few minutes. So we are back to the demo, and now I'm going to be running the comprehend step by providing the name of the report I want to generate, and I'm going to hit comprehend. So the output of the comprehend step is a named entity report. And when I open this report, you will see how different the output is from a regular word count or a search operation. These are not ordinary search results. So the skill has identified the entity, assigned it an entity type, and also indicated its exact position in the file that it has processed. Now, if you are a subject matter expert and you have a report such as this, you could focus on certain things that interest you and then go directly to those documents to understand what those topics of interest are doing in your documents. Now, in my case, the name Ericsson caught my attention. So I have the Ericsson group here on line 15. And then I also noticed the company Coca-Cola on line 26. Alternately, I could look for all organizations that have been mentioned in my documents by searching by entity type. Now, before we begin searching, I want to cover an optional step. This step is the highlight step. It would be nice if all the documents had these entities highlighted. And what the highlight step does is it takes the inputs from the previous step, that is the named entity report that we generated and the source documents, and highlights all the entities in the documents for you. Now, I've already run the highlight step, and we won't be demonstrating that here, but you could see how those documents will look when you open them up. So let's move on to the explore step. This is one possible way of how you would be utilizing the output of the named entity recognition skill. I'm going to be running a search for the two companies I'm interested in, Ericsson and Coca-Cola. There's Ericsson on page 256, Ericsson again on page 172, and there's Coca-Cola on page 504. So 3 documents have been opened up, but you might have noticed that these documents are spaced wide apart. But if you're a subject matter expert, you can quickly understand what these companies are doing in your document. For example, Ericsson has been mentioned in a case study. So if you're a sales or marketing SME, you can quickly comprehend how your subject of interest relates to this document almost immediately. And that's Coca-Cola. Now let me do the opposite. Let me try to search by all organizations that have been mentioned in my sample documents. So I'm going to flip the switch to search by entity types, and I'm going to explore the documents once again. So this time, 7 documents have been opened up. That's obvious because there are many organizations mentioned in my sample set. So each one of these pages has a major organization mentioned based on the outputs of the named entity recognition skill. So you can see the implications of this system if you apply it to your area of expertise. If you are in sales, marketing, or legal areas of expertise, you could quickly comprehend your documents based on a major organization, a major person, or a major law. So I hope I've been effective in demonstrating how you could leverage the named entity recognition skill to process large number of documents for your business. That is all for this demo, and I'm now going to hand it over to my co-presenter, Aram. Aram, please take it away.
Very nice. Thank you very much, Andy, for your presentation and your demo. I think it's very exciting and interesting about what you're doing with named entity recognition here, and also how you can integrate this so nicely into the UiPath apps system. So I think it really speaks to the usability and also the easiness to integrate of UiPath AI Center applications and model and out-of-the-box packages such as these. So thank you very much. I'll be taking it over from here. So as you can see, my name is Aram van Meurs. I'm a technical consultant at Incentro Automation, which is based in the Netherlands. And we pride ourselves in having a lot of experience with automating large and complex processes. Nothing is really too far-fetched for us. We really like to get in there and try to puzzle and get the most out of everything. So to test our skills with that, we also competed in the last year's UiPath HyperHack. We got second place in the AI Center category back then. And we carried that on, or at least I carried that on by also applying for and achieving the UiPath MVP title for this year, which I'm very excited about. Just as a quick one-liner, the way I would describe myself as an RPA professional would be that I'm a person who's very passionate about driving innovation within the RPA space. That's also how I want to use my role as an MVP, and also why I'm here on speaking for DevCon right now, to kind of try and share some inspiration to the rest of the UiPath developer community. So before we start off with the with presenting the demo, I want to start off with a bit of a mindset that we can all try to get ourselves into, which is what if we don't just think about UiPath and RPA and automation as a tool to enhance and improve existing processes, which is obviously great and works very well. I think we can all speak for that. But I think one of the great things about RPA is that we can also implement it with things like machine learning and artificial intelligence to go beyond just automating existing processes and also get into processes that might not be able, that we as persons, as humans, might not be able to do, and really find new value in combining the value propositions of RPA as well as artificial intelligence. So about the use case that we'll be reviewing here, the demo I will be showing you shortly is all about customer retention within telecom. And for that, we'll be using a couple of UiPath products, namely UiPath Studio, AI Center, and Action Center. Within AI Center, we'll be using a retrained TPOT XGBoost classification model. More on that later. The nice thing about this model is that it can also be retrained and repurposed for any other classification purposes. So it doesn't have to, you don't have to stick to simply or to telecom only. It can be any other use case as well, as long as you have the data for it, of course. Also, we use Action Center, which allows for handling potentially false predictions. And one last nice bonus about this setup is that it can also be improved over time by implementing a continuous improvement cycle, where we take data from the live situation, feed it back to the machine learning algorithm, and ensure that this algorithm keeps on improving itself over time. So what exactly is the problem we're trying to tackle here? Well, first off, let me describe one of the words you'll be hearing from me a lot, probably, which is the term churning. Churning is really a fancy word to describe the act of a customer unsubscribing from a particular service, in this case, from a telecom provider subscription. So why is this important? Why is this interesting? Well, the thing for telecom companies is that it's actually costs a lot of money and time to acquire new customers, because it's very difficult to find these new customers. Then in the same vein, it should also be very efficient and save us a lot of time and money to retain customers that we already have. So really, whenever a customer churns, this is effectively a very bad event in terms of efficiency, because retaining this customer would be way more efficient than trying to acquire a new one. So all in all, we can see that process improvements are quite desirable to not only improve efficiency, but also the quality of service that a telecom provider can provide. So the challenges we'll be trying to tackle with this solution really come down to the real life situation as it is right now, which is that customer service agents currently must try to prevent churning in a reactive manner. So this means whenever a customer is signing out of their contract, one of the customer service agents will try to prevent this and try to convince this customer not to drop out of their subscription. Of course, in many cases, this will already be too late to be effective, because, well, to be fair, as a customer, you've already made your decision, and you're probably not likely to be swayed by one of the customer service agents of the same telecom company. You've already had your reasons for signing out. So in that case, if we can't, if it's not efficient and very difficult to prevent churn in a reactive manner, why can't we do it in a proactive manner? Well, in this case, we have the problem where trying to manually detect churning customers in a proactive manner is very difficult and inefficient, because all these customer agents really have is a lot of single pieces of data about these customers and their contract information and their behaviors. But it's very difficult to find patterns in that data that might predict or might point out that this customer is likely to churn at all. So that is exactly why a machine learning algorithm, a machine can actually find these hard to detect patterns and act accordingly. So let me talk you through the architecture of the solution I will be showing you in a minute. Just to be clear, this is not a live demo. So a lot of these applications are purely for mock-up purposes, but I do think they very well, and they do a very good job of showing you what could be possible and hopefully inspiring you to build similar solutions. So what we have is we have the UiPath orchestrator, which will start off, it will kick off an unattended UiPath robot. And this robot will go through the telecom company's database and read out the customer data. This customer data is then sent to the machine learning model, and machine learning model will make a prediction about whether or not the customer is likely to churn. So from here on, we really have three different possible outcomes. First off, on the left over here, you can see that whenever the model makes a prediction with a very low confidence level, or rather, in this case, we take a threshold of 70%. So whenever the model predicts with a confidence of lower than 70%, we will not take any action by the robots, but instead the robot will send it over to Action Center for manual review by the service agents. Otherwise, another possibility is that the robot predicts with a high confidence that this customer is not likely to churn. Well, in this case, we can simply end the process because no further action is needed. Finally, it's possible that the machine learning model predicts a churning customer with a high level of confidence. And in this case, we want to take action as soon as possible to try and prevent the churn. So the robot will open up the CRM application, get the customer's contract information, and then use that information to send out a personalized offer to this customer, but via email. And finally, also log their response when it comes in. So finally, let's go through the AI Center model real quick. As I mentioned before, we will be using an out-of-the-box package called TPOT XGBoost classification. You can find this in the out-of-the-box packages section under tabular data. And we trained this model on a data set that can be found on kaggle.com, containing a lot of customer data for telecom companies. So this data set contains 7,000 rows of customer entries, and we use Python to do some pre-processing feature encoding. So the machine learning model can actually make sense of what is being, what type of data is being fed. Finally, we put this through a training and evaluation pipeline, which ultimately resulted in an accuracy of about 80% for a model. And of course, due to this, we can deploy it as machine learning skill in the manner that Andy has just showed you as well. So in that case, it can now be used within an RPA robot. With that all being said, let's jump right into the demo where I can show you what this would look like. Okay, so what we have here is the data that the robot will be working with. So you can see each row within this data set represents one row of customer data that will be sent to the machine learning model for interpretation. Now, there's a lot to take in here. So let me talk you through real quick. We have, for example, the tenure, which indicates how long a customer has been a customer for. We have various columns that indicate what type of subscriptions a customer currently has. And then there are several columns that indicate various payment details, such as the way, the payment method, their contract type, and their monthly charges. Finally, there are some personal details. These are all randomly generated, so don't worry about the privacy for now. But we'll use these details to have the robot send the personalized offers when it's applicable. Now, in this gray column over here, we can see the to-be predicted value. So this is the value the robot should be trying to predict if it were correct. Now, this is hidden from the robot. So it doesn't actually read this while trying to do the prediction. It's only for illustration purposes. And finally, these last columns will be filled in by the robot to show you what the prediction was, how confident the robot was about this prediction, and what type of action was being put out. Now, additionally, here we have a CRM demo application. Now, this doesn't look like much right now, of course, but this is mostly for illustration purposes. Because of course you can slot in any other application in your business situation instead. So this can be an SAP or anything of the sort, and this can be as complicated as you would like it to be. Also, we have an empty inbox right now, but this is where the responses of our customers that are receiving customized offers, their responses will be provided within this inbox, so the robot can read them out and also process them. And finally, here's our action center, which is where the actions for human employees will be sent to whenever the robots or whenever the machine learning algorithm has a confidence level of lower than 70%. So with that all being said, let's start off the robot. We can do this from Orchestrator, where we only have to trigger a new job. And since this is an unattended robot, we only have to select a machine in this case. And we will also input an input argument where we can say that we only want to do the first 30 rows for this demo. So let's start it off right now. And so the robot is now initializing. You can see it's opening all of the applications that it will need to be using. And from here on out, it will be making predictions based on the customer data that's being given as input. So for each of these rows that you're seeing filled in right now, all of the data is being sent to the machine learning algorithm. This algorithm has been trained on similar data, so it knows how to make a certain prediction on whether or not the customer is likely to churn. So you can see a couple of different outcomes in these predictions. For example, we can already see that one of the customers was predicted to churn with a high enough confidence level. So in this case, a personalized offer was sent to this customer. And we can already also see the responses to these offers coming in on the inbox on the right. Now, additionally, we can see some situations where, for example, the robot's confidence was lower than 70%, in which case this has been happening in the background. The robot will be sending an action to the action center for later human review. And in other cases, it will just simply put out no action at all because the robot is confident that the customer will not churn at all. So let's have the robot finish all of these 30 rows. There we are. So as you can see over here on the right side, we can see the inbox of the robot where 5 different offers have been sent to the customers that were predicted to churn. Additionally, we can see that there were 3 situations where the robot had a low confidence level, under 70%. So in those cases, an action center trigger was initiated. And I will show you in a minute what that looks like. So let's go to the action center. And we can see these 3 tasks being deposited by the robot. So we can assign these to ourselves. And what you can see here is actually exactly the same information that was available to the robot previously, but the robot had difficulty predicting it accurately. So instead, we can have a human agent go through this data and do some extra research on whether or not this customer is likely to churn. Now, since we only have a smaller data set that these human agents have to work with, we've got personal data. These agents can contact the customers through their phone numbers, for example. And in this way, it's actually quite easily possible to try and prevent churn in a proactive manner. So whenever they have done their research and they have made a decision on whether or not this customer is likely to churn, they can click the checkbox on the bottom over there and indicate whether or not they want to send an offer to this specific customer. Now, as you can also see in the message box on the screen over here, is that the robot, since we're working with a long-running workflow, the robot is still listening for the inputs from the human agents. So the robot can still interpret whether or not an offer is desired to be sent to these customers or not. And based on that, of course, we can have the robots do further actions. Thank you very much for attending. Again, it's very exciting to be here and talk to you. So I hope some of that excitement came through to the screen at this moment. Okay, well, thank you very much, Andy, for joining me here. At least if I speak for myself, I'd like to plug in a little bit of well, a little bit of fame there and cash in on that. So if anyone has been listening to this and has been watching this and would like to know more about the solution that I pitched and proposed over here, feel free to reach out on the email address stated here. Andy, if you have any closing words, go right ahead, man.
Yes, thank you very much. It's been a pleasure. Like Aram said, please feel free to reach out if you have any questions about how you could use some of the technologies that we demonstrated, and we'll be more than happy to help you out.
All right. Well, that settles it then. Thank you very much for joining, and we'll see you guys on the World Wide Web, probably. Bye-bye.
Bye now.